In this video, I will be showing you the 2010 AMC 10B number 16. A square of side length 1 and a circle of radius square root of 3 over 3 share the same center. What is the area inside the circle but outside of the square? So the first thing I want to do is see how the image with the square and circle look together. So there are three options. The square could be all-encompassing of the circle. They could each partly encompass each other, or the circle could entirely encompass the square. Now to find out which one of these three it is, I'm going to be looking at two measurements, the vertical length and then the diagonal length. So for the vertical length, this one is just going to be the radius, which is square root of 3 over 3. And for the square, since it has a length of 1, that means that it also has a length of 1 over here, and since this is half of it, it is going to be 1/2. So we can see that the circle has a bigger vertical length. So we know that it cannot be this first option, because in this first option, the square has a bigger vertical length. So now we need to decide whether it's this one or this one. And to do that, we're going to look at the diagonals. If the square diagonal is bigger than the circle one, then it's going to look like this. And if the circle diagonal is bigger than the square diagonal, it's going to look like this. So again, these circle diagonals just going to be the square root of 3 over 3. And then to find the diagonal of the square, I'm going to use the Pythagorean theorem. So we basically have a square with 1 and 1, and we need to find this length over here. So it's going to be actually we just need to find the radius of it, so it's just going to be this length over here. It's going to be 1 squared plus 1 squared, square root of that to find this whole length, and then divide it by 2 to find this half length. That's going to be the square root of 2 over 2. And if we compare these, now you don't have your calculator on this test, so you're going to want to make it as improper as possible. So I could think this is going to be bigger because the square root of 2 is going to be a smaller number. And so when you put 1 into the square root of too many pieces, it's going to be a greater number than if you have to put it into more pieces. So that means that this is bigger, which means that the shape that we're looking for has a greater diagonal on the square and a greater vertical length on the circle. So I can erase this, now I know what the image I'm looking for looks like. And we'll be able to go from there. If anybody knows if you're supposed to clean this or not, comment down below. Okay. So that's the circle and that's the square. Again, the square is partly out and the circle is partly out. And now what I'm going to do is I'm going to want to create some triangle over here so that it's aligned with this vector, or this sector, and then we can find the sector area and subtract it from the triangle area. So this length right over here is just going to be square root of 3 over 3 because it's the radius of the circle. And then this length right over here is going to be 1/2 because this plus this is 1, so it's 1/2. And now, to be able the equations to find all this stuff, I'm going to have to find this length right over here, and then I could plug in the 2a length because there's also an a right over here, and I can use an equation with the degrees and how long that length squared is to be able to find the area of this whole thing, and then hopefully I'll be able to find the area of the triangle and subtract it, and then multiply by 4 to only get this area right over here. So again, I'm finding this whole area, subtracting it from this area, which would give me this one, and then I need to multiply it by 4 so that I can include all 4 of these. So I'm going to say, I can use the Pythagorean theorem for this. I'm going to say a squared plus 1/2 squared is going to be 1/4 is equal to square root of 3 over 3, and as we've said before, that is equal to, square root of 3 over 3 squared. That's going to be square root of 3 squared, which is going to be 3 over 3 squared, which is 9, so we are left with 1/3. And so it's going to be equal to 1/3. Now, so that you guys don't have to go through the trouble of listening to all this Pythagorean theorem mess, I'm just going to tell you that a is the square root of 3 over 6, which means that this 2a length, this whole length right here, is going to be the square root of 3 over 3. No, that's the same length that we have over here. I'm just going to put that in. Okay. So now since this is the square root of 3 over 3, not over 6, and this is the square root of 3 over 3, and this is also square root of 3 over 3, this is an equilateral triangle. And we're going to use that a bit later on. So right now I need to find the area of the sector, and that is going to be pi times this length squared, the square root of 3 over 3 squared, times the angle that this is, and since this is an equilateral triangle, all the angles have to be 60 degrees, so it's going to be times 60 over 360. I have no idea what just happened there. Okay, and so this is going to be, like we showed before, 1/3 times pi times 60 over 360, that's going to be 1 over 6. So this is equal to pi over 18, which means that this whole length right over here, this whole area right over here, is pi over 18. Now all I need to do is find the area of this equilateral triangle, and then subtract it from this one, multiply by 4, that's my answer. I'm just going to write this over here so I don't forget it. And then I'm going to figure out the area of this equilateral triangle. Now to do that, I'm going to use the equation to find the area of an equilateral triangle. And so it's going to be s squared times the square root of 3 over 4. And again, s squared is equal to the square root of 3 over 3, so s squared is going to be 1/3, so it's 1/3 times the square root of 3 over 4, which is the square root of 3 over 12. So now I take this length minus this length, and that gives me the area of this right over here. And now I want to find out in the questions is the area inside the circle, but outside the square, that's going to be this and this and this and this. So I need to multiply by 4 to be able to find all of this. So this right here is going to be my answer. Normally the 4 is written on the left side, but it doesn't really make a difference. Anyways, thank you very much for watching, and goodbye.